2.6 Implicit differentiations. So up to now, the type of equations and functions that we take derivatives are called the explicit, right, um, functions, because the functions or equations can be written as one variable in terms of another. But in many cases or in many equations, we cannot rewrite it in terms of explicitly. So we need to come up with a technique to take different derivatives for those equations, and we call it implicit differentiations. So the notations that we're going to use in implicit differentiations are Leibniz notations, which is dy dx. The important parts that you need to look at in this implicit differentiation is the y as a functions of x, right? So therefore, when we take the derivatives of y, we need to carefully look at, is this going to be composition functions or not? Like for example, if it is y squared in the equations, then this become a composition function because we are looking at f of x and then quantity to the square. So you can see that the outer function is a square functions and the inner function is what? F of x. So in that kind of situations, you need to clearly see that the y square is like what? A composition function, so that you will be taking derivatives by using the chain rule. Right? So let's take a look at on these example. Like for example, part A, we have x squared plus y squared that is equal to 25. And when we take derivative respect to x, right, derivative of y respect to x, that basically tell us, right, when we ask you to find derivative of y respect to x, that basically tell us we are looking at y as a functions of x. Okay. So when we look at this and then taking derivatives on both sides of equations, this is how it's going to look like, right? Derivative respect to x and taking derivative on both sides of equations. And then using the formula, derivative respect to x of the first term plus derivative respect to x of the second term. So for this problem, I'm going to write it down step by steps to help you to see it. Derivative of a constant is what? 0. Now, this is already function by itself already, x squared with the power function. So when we take derivative respect to x, this will give us what? 2x. Plus, but however, right here, you can see that it's y squared. So we have to look at that as what? A composition function. So therefore, what we need to do is first, we need to take derivative of the power. So that will give us 2, right? And then what? Y, and then taking away 1 to the power. And then times with derivative of inside functions, the inside function will be y, right? Because you need to look at y as a function of x, so y squared as this format. So therefore, now when we take derivative inside of functions, that will be derivative of x respect to derivative respect to x of y, the inner function. So don't forget, this is an equation is equal to 0. Now, we will get next step will be 2x plus 2y, and then this derivative of y respect to x will be multiplying with what? Dy dx, which is basically y prime that we can write it down. So now what we're going to do is we're going to solve for dy dx. So dy dx, we subtract negative 2x on both sides and divide by 2y. So therefore, my final answer, in this case, dy dx, that is equal to negative x over y. And that will be my final answer, because the question asks you to find derivative of y respect to x. So this is the first equation. And once you understand how to look at, carefully on these part, then you can skip all of this step. Meaning, if I'm doing, later on, if I have enough practice, and then when I'm taking derivatives, right away I will be writing down the, taking the implicit differentiations and then writing down the answers, such as 2x plus 2y times y prime, that's the chain rule, that is equal to 0. One step, I'm done with my derivatives. And from there on, I can solve for y prime, which is dy dx. Let's take a look at on the next example, example B. Right? So example B is x to the third plus y to the third is equal to 6xy. So it's a little bit more complicated because on the right hand side, we're going to have to use what? The product rule. So when I take derivatives on both sides, derivative respect to x of x to the third plus y to the third, that is equal to derivatives respect to x of 6xy. So on the left hand side, taking derivative of each term, and on the right hand side, since this is a constant, I can take it out the constant, and I can use the product rule right here. So when I use the product rule, that will be what? Derivative respect to x of the first factor times with the second factor plus the first factor times the derivative respect to x of the second factor. So when I take derivative, that will become 3x to the second power plus taking derivative of the power first, that will be 3y squared. And remember, y is a function of x, so derivative of inner functions, y will be what? Dy dx. Let me write it down for the later purpose. So derivative respect to x of the inner function, which is y. That is equal to 6 times derivative of x is 1, so 1 times y plus x times derivative of y respect to x will be dy dx. So now, finally simplifying a bit more, it will be 3x squared plus 3y squared times with dy dx. And it is equal to 6y plus 6x dy dx. And now we want to solve for derivatives, right? Dy dx term. So that will be 3y squared dy dx minus 6x dy dx is equal to 6y minus 3x squared. Everything can be divided by 3. So, I'm going to divide everything by 3 and also factor out dy dx. Right? So this will become y squared minus 2x times with derivative of y respect to x, that is equal to 2y minus x squared. So therefore my dy dx, that will become 2y minus x squared all over y squared minus 2x, and this will be my final answer. So, writing out step by step will help you to get used to with y as a functions. Y, the variable y in the equation is a functions of x, and then so that you will be able to see that y to the third power, or like, y to the second power, or tangent of y, those as a composition functions, and then take the derivatives, right, using the chain rule. So from now on, what I'm going to do is I'm going to skip all those steps and then start writing down just the answer. Right? So let's take a look at on example C. So when you take derivatives respect to x on both sides, and y to the fourth power is a composition function. So when I take derivative, that will be 7 times taking care of the power function first. So it will be 4 y to the minus 1 power, so it will be y to the third, times with now derivative of inside functions, which is going to be what? Y prime. Right? Because dy dx, I'm going to write it down as y prime to make it the notation simpler. And then plus, now I need to, for the second term, I need to use the product rule. Right? So first taking derivative of the first factor, which is bringing it down 3, and then that will be left with x to the second power times with the second factor, which is y, and then plus first factor times the derivative of the second factor, which is derivative of y respect to x will be dy dx. And then plus the last term, derivative of x is 1, equal to derivative of a constant is 0. So now I can simplify it, right? That will give us 28 y to the third power y prime plus 3x squared y plus x to the third y prime plus 1 equal to 0. Solving for y prime, so on the left hand side, I can basically factor out y prime from these two terms. So this will give us 28 y to the third power plus x to the third power times with y prime. That is equal to the other term. I bring it to the other side. That will be negative 3x squared y minus 1. And finally, dividing by the factor on both sides, that will give us 28 y to the third power plus x to the third power. And that will be my final answer for C. So let's take a look at on example D. So for example D, when I take the derivatives, right, respect to x using implicit differentiations, for the first term, when I take derivative of the first term, 5 is a constant, so write it outside. And then I need to take care of the power, so which is going to be what, 2, and then y to the first power. And then taking derivative of inner function, which is y, that will give me dy dx, which is y prime. And plus, now for the second one, notice that I have a sine outer function, sine functions, inner function is y, which is a function respect to x. So taking derivative of outer functions, which is derivative of sine is cosine, right? And then inside will be stay the same, y, times with derivative of inside function, which is the derivative of y, that will give me y prime, equal to, on the other side, the power functions. So bring it down 2, right? And then minus 1 to the exponent, so which will be 1. So now simplifying a bit on this. So this will be 10 y prime plus cosine y times y prime is equal to 2x. So factoring out and then dividing both sides by the 10y plus cosine y. And that will give me my y prime, which is the final answer. Let's take a look at on example E. So for example E, before we take in the derivative by implicit differentiation, left-hand side is very complicated. So the first thing that I need to see is the most outer function is the third power, and then the tangent functions. And then finally, it will become what, xy squared plus y, 2 terms. And in that 2 terms, I need to use what, chain rule right here, right? Y squared as a function. So it's very complicated. You need to carefully use this chain rule right here when we do like, if you don't write it down step by step. So taking derivative of the power first, so that means bringing down the power and then minus 1 to it. So it will be tangent to the second power, and everything inside, like, inner functions will be stay the same right here. So that's why I'm writing down tangent and then what, xy squared plus y. And according to the chain rule, you're going to multiply and then take the derivative of the next inner functions. So I'm done with this. Next inner function, we are looking at what, tangent. So derivative of tangents is secant square. So secant square, and then inner functions is everything the same thing. All right, inner function is everything the same thing, which is what, everything below of that. That means I will have xy squared plus y. And then lastly, I'm going to be taking care of the last inner function, which is this one. And this, I need to use like 2 terms. So you really need to write it down carefully, which is multiplying with what, the whole derivative. So I'm going to put it inside the big parentheses, right? Or braces, whatever you want to use it to indicate that this is going to be a derivative of the entire, this 2-term binomial, right? And when I take derivatives, first term, I need to use the product rule, right? For this one, I need to use the product rule and then chain rule. So using the product rule, taking derivative of x will be 1, and then times with the second factor, y squared, and then plus x times derivative of the second factor, which is 2y. Now I have to use the chain rule. So taking care of power first, that will be 2y to the first power, right? And then derivative of inner function, which is y, that will be what? Times with y prime. All right? And then this finishes up this first term. So that will be plus, and a derivative of the second term, which is y by itself. So that will be just y prime. And then I'm going to close the braces, and that will be equal to, on the right hand side, derivative of x, which is going to be derivative of x respect to x, which is going to be 1. So notice that this is a very lengthy, derivatives right here, and then you really need to be careful with that. So when we are simplifying this, right? When we are simplifying this, what happened is all of this are factors, so I can divide it to the other side, and then we'll take care of the inside portion. So that means I will on the left hand side, I will left with y squared plus 2xy prime plus y prime equal to 1 over that whole entire factor, 3 times tangent square xy squared plus y times with secant square xy squared plus y. Then I'm going to try to subtract y squared on both sides, and then divide it by, after factoring out y prime, we will divide it by the remaining factor. So this will be 2xy plus 1 times y prime equal to this entire fractions minus what? Y squared. Right? So moving back this entire fractions right here. Now, finally, what I need to do is what? Divide by this 2xy plus 1 to both sides. Another way of saying is this will become y prime is equal to, I will have this, but in the denominator, since I'm multiplying by reciprocal of that, I will have an extra factor, which is going to be 2xy plus 1 minus y squared over 2xy plus 1. So I divided both sides by this. And you can simplify further if you want to put it into the LCD or use the trig identity. But at this point, I'm going to stop right here. Okay? So it's basically like, getting lengthy and ugly when you need to simplify this stuff. All right. Now let's take a look at our next example. So this time's the rational part involved in the equations, but we're still gonna take the same way, the same formula as before, just basically looking at y as a function of x. So when I take derivative with respect to x on both sides, on the left hand side, bring down the power, and then that will be what? Minus 1 to the power, so x to the first power. That is equal to, now we're gonna take the derivatives of the quotients. So we take the derivative of the numerator first, which will become 1, right? The first term is 1, plus derivative of y, that will be y prime, right? That will be y prime. And then multiply with denominator, which is x minus y, minus the numerator, which is x plus y, times with this time derivative of denominator. When I take derivative of denominator, derivative of x will be 1, and then minus derivative of y will be y prime. And then denominator square, that is the quotients formula. Now, what we need to do is we need to solve for what? The y prime. So that's the part that, you need, your algebra needs to be like really good so that you can finish it up quickly and correctly. So multiply both sides by the LCD, get rid of the denominator, and then I'm going to be distributing it, this x minus y, or foiling it, whatever you want to call it, to that. So it'll be x minus y, and then plus xy prime minus y prime, right? Minus x times 1 is x, and then x times negative y, and the negative will be plus xy prime. And then the second terms, that will be negative y, and then positive y prime. That's what we get. So what you can do, you can see already, these two terms will be eliminated out, right? And then the other terms, like, I only need to left this two terms, and the rest will be getting rid of it also. And then we can see that this x term and then minus x term will be gone also. So when I simplify a little bit, that will become 2x minus y squared, which will become minus y, negative y minus y will be negative 2y, plus xy prime will give me 2xy prime. So when I factor out y prime and then divide it by the other factors on both sides, that will give us negative 2y. Oh, my bad. I made a mistake right here. Right? I need to add first. Oh, let me divide everything by 2, so to make it easier to, instead of keep on writing that constant. So clear as much as possible. And then this will become x minus y squared plus y. And then you divide everything by x. And this will be my y primes, which is the derivative that we are looking for. So let's take a look at on the next example. So for this problem, we can take derivative respect to x, right? By using the implicit differentiations, and on the left-hand side, we can use the quotient rule, and then take a derivative on the right-hand side. So being said that, this, when I take derivative on the left-hand side using the quotient rule, on the numerator, what I need to do is I need to use the product rule. So derivative of the first term will be 1, right, times with y to the third power, and then plus the first factor times the derivative of the y to the third power with respect to x. So we'll take care of the power first, which is going to be 3y squared, right? And then taking derivatives, of the inner function, which is y, that will become what? Y prime. So we take care of the numerator part, derivative of that. And then according to the quotient rule, I need to multiply by the denominator factor. And then minus, now I'm going to multiply the numerator times with the derivative of the denominator, which is derivative of the denominator, derivative of 1 will be 0, and then plus derivative of secant y. So in this case, my outer function is secant, inner function is y. So taking care of the outer functions will be secant, derivative of secant is secant, and then tangent, right? And then the inside part is the same, so secant of y times with tangent of y. And then finally, multiplying with derivative of the inner function, which is derivative of y respect to x, that will be y prime. And then denominator square, this will be 1 plus secant y quantity square. Equal to, now on the right hand side, derivative of 1 is 0, and then plus with derivative of the y to the fourth power, that is we need to use the chain rule. So bringing down the power, so which will be y to the third power, and then times with derivative of inner function, which is y prime. Now, what we are interested in, what? Simplifying this complicated, functions. So one thing that we can do is distribute it so that you can get your y term by itself, right? So this will become y to the third power and times with what? 1 plus secant y, and then plus 3xy squared times with 1 plus secant y times with y prime, okay? And then minus, when I distribute it, that will become xy to the third secant y tangent y y prime equal to 4y to the third y primes, and then you're going to multiply both sides by this 1 plus secant y quantity square. So I will have 1 plus secant y quantity square times with y prime. Then what we want to do is we want to put all the y prime terms on one side and then the rest on the other side. So the easiest way to do is move this y, the right hand side y prime into the left hand side and then work on it, right? So being said that, what I will do is I will try to copy and paste, not this part, only this part. Give me a second. Something went wrong. So only this part right here, I'm gonna copy and paste it because this is the two term that I'm gonna left it on the left hand side, right? And move it a little bit to the left because it's gonna be a long process. Good, so I don't have to copy down everything in here. So now I'm gonna be subtracting this 4y to the third 1 plus secant y quantity square y prime, and then on the right hand side I'm gonna have to move this term to the right hand side. So I'm gonna be subtracting that to both sides. So it will be minus y to the third 1 plus secant y. So now factoring out y prime and then divide everything by what's left over, and that will give us y prime is equal to minus y to the third power and then 1 plus secant y, and then all over the whole things right here, right? So I can move this right here a little bit. Remember, we need to get rid of this y prime also. Y prime right here, and then put an extra minus 4y to the third 1 plus secant y to the quantity square, and then all over on that. And that will be my final answer. So it looks a little bit complicated. You know, if you want to simplify further, you can try it out using the identity, but this is good enough. Let's take a look at on H, right? So taking implicit differentiations right here on the left-hand side, I will see that my outer function will be 1/2 power. The inner function is 1 plus 2 term, which is 1 plus sine to the third power x, y quantity square. So for this portion, I have to see that the outer function is the cube function, right? When I use the chain rule for this part. And then the next function will be sine functions, and then the next function will be what? The product, which is y to x, and then x to the second, and I need to use right here the chain rule again. So it's a little bit, this is going to be a long and complicated also, right? So now let's take a derivative of this. So when I take derivative of this power functions, that will become 1/2, and everything inside the same, right? The inner function is the same. And then to the what? Negative 1/2, because when you subtract it by 1. So that will be negative 1/2 power. And this is basically inside will be 1 plus sine to the third power xy quantity square, xy square. Now times with, we're going to take derivative of inside functions, right? So when we take derivative of inside function for this part, derivative of 1 is 0. And then plus Now we're going to take derivative of what? The second term, which is the power function first. So you bring it down 3, and then sine of xy squared, because all the inner function is stay the same, and subtract 1 to the power will be 2. Times with, because I'm not using the chain rule now, I'm done with this part. Now the next part is I'm going to take care of the sine. So derivative of sine will be cosine, and then everything inside of the cosine is the same, right? So which is going to be what? That will be xy squared. And then times with now derivative of the last part right here, which is we're going to use the product rule. So using the product rule, derivative of the first factor, which is the derivative of x, will be 1 times with y squared, and then plus with x times derivative of y squared, which is I need to use the chain rule right there. Right? So this will be bringing down the power and then y to the first power. And then times with what? Y prime, derivative of inner functions. And that's completed my derivative on the left-hand side. And equal to derivative on the right-hand side, derivative of y respect to x will be y prime. Now we need to simplify to get our y prime. So remember that this is 2 factor, and this factor is in the denominator because of -1/2 power. So I'm going to multiply both sides by the reciprocal, right, to get rid of this factor, which is going to, on the left-hand side, which we're left with 3, right? 3 sine squared xy squared cosine xy squared times with y. That's for the first factor, right? I'm distributing this whole entire part to the first factor. And then plus 2xy y prime times this whole thing. So that will become, it will be 6xy sine squared xy squared cosine, right, xy squared, and then y prime. Right? Now I'm distributing to the second term, because 2 times 3 is 6, and then xy, and then this whole equal to, since I multiply both sides by the reciprocal of this, which is mean I multiply both sides by 2, 1 plus sine to the third power xy squared quantity to the 1/2 power y prime. Okay, y prime. And let me write down prime a little bit tilted so that you will not mix up with the first power. So now what we're going to do is what we're going to have to move one term to the other side. So I will have 3 sine square xy square cosine xy square y square. That is equal to 1 plus sine to the third xy square quantity to the 1/2 power y prime minus this whole term. Okay, minus this whole term, so that all my y prime will be on one side. Right, all my y prime will be on one side. So now what I will do is I will factor out y prime and divide both sides by this, right? So it'll be 3 sine square xy square cosine xy square y square. And I'm going to divide everything by this whole thing. So that means I'm going to divide everything by this whole thing. All the way down to here. But we're going to get rid of this, a few of the y prime, right? Equal to y prime. And that is my final answer in this case. So now that we know how to take derivative implicitly, then we can continue on many problems. Right? So one of the problems that we want to look at is the old ones, right? Finding the equation of the tangent line. So first, what we need to do is we need to find out the slope of the tangent line at that point 3. So that means I need to find the look for dy dx. So to find out the slope of the tangent, right? And we basically take derivative respect to x. So implicitly taking the derivative respect to x on this part will be what? 2 x to the first power y, right? Derivative of the first term, plus derivative of the second term, which is x squared times y prime, and then minus, now I need to take the derivative of the second term again, right? But using the product rule, so I will be minus 5. Derivative of the first term, the first factor, which is going to be x is 1 times y squared, plus derivative of the second factor, which is x times 2y, y prime, and then plus derivative of a constant is 0, and derivative of a constant on the right-hand side is also 0. So this gives us, let me put my y prime a little bit tilted so that I will not get confused with the first power. So this gives us 2xy plus x squared y prime minus 5y squared minus 10xy y prime equal to 0. We want to solve for y prime, so this will be x squared minus 10xy times with y prime equal to, moving on the other side, 5y squared minus 2xy, and then my y prime, that will be equal to 5y squared minus 2xy all over x squared minus 10xy. So we want to find out the slope of the tangent lines, and on this curve, this is a general formula. So if we want to find out the slope of the tangent line at x equal to 3, that is basically we are evaluating y prime, okay? Evaluating y prime at, right, at the 3, 1. Because notice that y prime is a multivariable function now. I have 2 different variables. So I need to use this whole order pair, which is 3 is a corresponding, the output value of 3 corresponding to is 1. So this will become, I will get 5 times 1 squared minus 2 times 3 times 1 over 3 squared minus 10 times 3 times 1. And which will give us, that will be 5 minus 6 will be negative 1 on the numerator, all over 9 minus 30, which is going to be negative 21. So I got my slope 1 over 21. Now I have the slope and I have the point. I can find out my equation of the line, right? So my slope in a point, so y minus y1 equal to m x minus x1, which is y minus 1 equal to 1 over 21 times x minus 3. That gives us y is equal to 1 over 21x minus 1 over 7, and then plus 1. So therefore, my final answer is y is equal to 1 over 21x plus 6 over 7. The last example we want to take a look at is finding out the second derivative. And this is where you really need to simplify and then know how to simplify well on after you take the first derivative, so that your second derivative will be much easier. And this problem is very not hard. So when I take derivative respect to x implicitly, x to the fourth power, that will give me 4x to the third power plus derivatives respect to x with y to the fourth power, that will be 4y to the third power times with y prime is equal to derivative of constant is 0. So therefore, y prime is equal to negative x to the third power over y to the third power because I divide both sides by 4. Now, when I take derivative with respect to, um, x for the second times, so that means my second derivatives, that is basically taking derivative of this part, and that will be using the quotient rule, which is derivative of the numerator. That will give us 3x to the second power times what the denominator minus the numerator times with derivative of the denominator, which is 3y to the second power times with y prime, right? And all over y to the third power quantity squared. So this will give me y double prime is equal to negative 3x squared y to the third power minus 3x to the third y to the second power times with the y prime. We don't want y prime in this situations. So we're going to substitute this y prime with what we found out we already simplified, which is negative x to the third y to the third power. So this is the part that I'm talking about. You need to know how to simplify y prime so that you can make it a lot easier on simplifying on the second derivatives. So finally, when I continue on this, okay, and notice that for this part, it will be negative 3x to the second y to the third minus 3x to the third and x to the negative and negative become positive. X to the third and x to the third, that will give me x to the sixth power. And y squared and y to the third power, so that will be times with 1 over y. That's what's left over, y to the sixth power. And then finally, what you can do is you can get rid of this y, 1 over y by multiplying top and bottom by y, which will give us negative 3x to the second y to the fourth power plus 3x to the sixth and then y to the seventh power. And that would be my final answer. So you need to practice a lot on this. And don't forget to do the homework.